Okay, student. Now we just see one small topic, and which is very important topic for the GATE examination point of view, sensitivity. Now, what is the use of the sensitivity? How to calculate the sensitivity of any system? We will calculate, but now first you see here. Now this sensitivity is used to measure effectiveness of feedback. Now what should be the effect of feedback? So you can measure with the help of sensitivity. Next, sensitivity is used to describe the parameter variations. Sensitivity is used to describe the parameter variations like forward path gain, G of S, comma, feedback path gain, H of S, system gain, K, and so on. Okay, so you can understand, not a problem. Okay, sensitivity is used to measure the effectiveness of feedback, and which is used to describe the parameter variations like forward path gain, feedback path gain, system gain, and so on. Okay, so how to find the sensitivity and how it is useful to us? Okay, we will check first. Okay, now for any problem, for any system, whatever he is given, so how to find sensitivity we will see. Okay, so now first you note down, this is the sensitivity, the importance of the sensitivity, why we are using the sensitivity. Now see here, sensitivity, this is the sensitivity factor denoted by S, sensitivity factor denoted by S, alpha with respect to beta. Okay, sensitivity factor represented by S, alpha with respect to beta. So this is the notation. This is a small change in alpha to the small change in beta, which is nothing but d alpha by alpha d beta by beta. Therefore, which is nothing but beta by alpha into d alpha by d beta. Now this is the sensitivity factor S, alpha with respect to beta. Sir, then what is alpha, sir? What is beta? Then that I want to explain. Alpha is the variable that changes the value itself. Alpha is the variable that changes the value itself. Beta is the parameter is used to control the value of alpha. Okay, so for better understanding I will take one small example such that we can easily understand. Okay, not an issue. So I just take one small example. First you just recollect this. G of S, which is equal to K by S. This is one open loop control system transfer function. Now this I converted into a closed loop control system, means now you find characteristic equation. The characteristic equation is 1 plus G of S equal to 0, which is equal to 1 plus K by S equal to 0, which is nothing but S plus K equal to 0, S equal to minus K. This is the closed loop pole. Okay, S plus K equal to 0, S equal to minus K, closed loop pole. Now see here, sometimes sometimes your closed loop pole may be at origin, sometimes your closed loop pole is at -1, sometimes your closed loop pole is at -2, sometimes your closed loop pole is at -5, sometimes your closed loop pole is at -infinity, right? Now these are the closed loop poles, is at origin, at -1, at -2, at -5, at -6 and so on, right? These are the closed loop pole which is varied, am I right? Not. So now you see here, so this closed loop pole is a fixed or variable? Variable at origin, at -1 or at -2, at -3 and so on, right? So you just compare this alpha, I can represent it with S, which is nothing but closed loop pole. Now you can understand the definition. Read. S is a closed loop pole, is nothing but is the variable that changes the value itself. Sometimes it is at origin, sometimes it is at -1, sometimes it is at -5, sometimes it is at -2. It is a variable. Okay. So S is the alpha, means for understanding S is nothing but alpha. What is alpha? Alpha is nothing but variable that changes the value itself. Now I am asking one question. Who is saying that the closed loop pole is on -1? Now, when k equal to 1, then only the closed loop pole is at -1. When k equal to infinity, then only the closed loop pole is at -infinity. When k equal to 0, then only the closed loop pole is at origin. When k equal to 5, then only the closed loop pole is at -5. Therefore, this closed loop pole is controlled by system gain k. System gain k is the closed loop pole which is used to control the system gain is the closed loop pole. System gain is used to control the closed loop pole. Am I not? Now see, so this beta is nothing but system gain k. This is the system gain. This is the system gain. Now this is the system gain k, which is used to control the value of alpha. See, beta is the parameter which is used to control the value of alpha. Okay, then that beta is nothing but, for understanding, you can take it as a gain. That alpha is nothing but, for understanding, you can take a system gain. System closed loop pole. Yes, then you can consider one formula here. So yes, sensitivity factor S of S means a closed loop pole or whatever it may be. Now, with respect to whatever may be you write with respect, that is nothing but a controlling parameter. With respect to k, what is the formula? Whatever may be the denominator, that you can take first. Here it is beta, beta by alpha. Here it is x, x by. Here it is y, y by. Okay. So this is beta. Here it is k. So k by s into reverse. Now reverse with the differentiation. ds by dk. Now this is the sensitivity factor. If you find at a particular pole, if you find at a particular location, this is called as Routh sensitivity factor. This is called as Routh sensitivity factor. Okay, that is called as Routh sensitivity factor. Now if you find the sensitivity, if I want to find the sensitivity of a control system. So for a control system, if you want to find the sensitivity, means first you want to find the transfer function of the control system. So this is the control system, means control system transfer function. Now with respect to means controlling parameter, with respect to forward path gain, which means that denominator first g by t into dt by dg. This is the sensitivity of the control system with respect to forward path gain. No sir, I want to find a sensitivity of the control system. I want to find the sensitivity of the control system. Now with respect to feedback path gain, which is equal to h by t into dt by dh. This is the sensitivity of the control system with respect to feedback path gain. Like that you can find anything. Okay, that's why the sensitivity which is used to describe the parameter variations like forward path gain, feedback path gain, system gain, x, y and so on. Okay, note down this. Now see how the questions based on the sensitivity. Okay. Now by considering the following block diagram, now he is given my block diagram to you. Now this is the block diagram which is given to you, and he is asking sensitivity at breakaway point. Where he is asking? He is asking to find the sensitivity. He is asking to find the sensitivity at breakaway point. So he is asking to find the sensitivity at breakaway point. So now you just find here. Now you want to find the sensitivity at a particular point. I am already saying to you, if you want to find the sensitivity at a particular pole, at a particular location, at a particular value, at a particular root, that sensitivity is called as root sensitivity factor. Now that is the formula you can utilize. So first of all, we want to find the breakaway point. How to find the breakaway point? First you find the breakaway point. So for finding the breakaway points, we require characteristic equation. This is the step 1. Characteristic equation we required. 1 plus g of s equal to 0. Therefore, s into s plus 2 plus k equal to 0. S square plus 2s plus k equal to 0. This is the characteristic equation. Now, this is the procedure to find the breakaway point. Step 2 is k function of s, k function of s, k which is equal to minus s square minus 2s, k which is equal to minus s into s plus 2. This is system gain k. Now step 3, differentiate k with respect to s and equate to 0. Now differentiate k with respect to s and equate to 0 and find roots. So this is dk by ds, which is nothing but minus 2s minus 2, which is nothing but minus 2 into common s plus 1. Therefore, dk by ds is equal to 0. Therefore, minus 2 into s plus 1 equal to 0. S plus 1 equal to 0. S equal to minus 1. This is breakaway point. Clear or not? So, first characteristic equation, k function of s, differentiate k with respect to s and equal to 0, find the roots, and this is the breakaway point. And you already know that. See here, this is one pole at origin. This is one pole at origin, and this is one pole at minus 2. Now between these two poles there exists a root locus branch. So definitely as k is changing, closed loop pole is moving. As k is changing, closed loop pole is moving. These two closed loop poles are meet at a particular point. Now that particular point is called as breakaway point. That particular point is called as breakaway point. Now this is the breakaway point of s equal to minus 1. Now at this particular point, now you want to find the sensitivity. That sensitivity is called as root sensitivity factor. Therefore, what is the formula? S of breakaway point of s with respect to k, which is nothing but k by s. What is k by s? Now see here, from here what is k by s? From here k by s, which is equal to minus of s plus 2, minus of s plus 2. This is k by s. And ds by dk. Now ds by dk, which is nothing but ds by dk, but we have dk by ds, therefore we can take reverse, ds by dk, which is equal to 1 by minus 2 into s plus 1. So 1 by minus 2 into s plus 1. So s plus 2 by 2 into s plus 1. This is the sensitivity at breakaway point of, this is the sensitivity at breakaway point of s equal to how much? Minus 1. Substitute here, what happened? Now this is nothing but minus 1 plus 2 by 2 into minus 1 plus 1. Therefore, this is the sensitivity at breakaway point of s equal to minus 1, which is equal to something by 0, which is infinite. Now this is the sensitivity at breakaway point, and we use this is the sensitivity factor. So if you want to measure the sensitivity at any particular point, then you just use the root sensitivity factor formula. Okay, note down. This is the formula which we are used here. Sensitivity factor which you can utilize. Now if he is asking to find a sensitivity at any particular pole or at any particular location or at any particular value. Now this is the block diagram which is given to you. By considering the following block diagram, what he is asking is by considering the following block diagram. Now what he is asking is, he is asking to find sensitivity of steady state error with respect to k and with respect to a. So you understand, he is not asking the sensitivity of a control system. He is asking the sensitivity of steady state error with respect to k, with respect to a for unit ramp input. This is the question. By considering the following block diagram, determine sensitivity of steady state error with respect to k and sensitivity of steady state error with respect to a for unit ramp input. Now first you write the formulas for that. So what he is asking? He is asking to find sensitivity of steady state error with respect to k. With respect to k, what is the formula? First denominator, k by steady state error into differentiate steady state error with respect to k. This is one formula. Next, what is asking? Sensitivity of again steady state error with respect to a, which means first denominator, a by steady state error, differentiate steady state error with respect to a. So this is the open loop transfer function. Now this is g of s, which is equal to k by s into S plus A. Now, this is type 1 control system. This is type 1 control system. Now, which input? Input is unit ramp input. T power 1, unit ramp input. So, now type and power both are same. Type equal to power. Type is 1, power is 1. Okay. Type is 1, power is 1. Therefore, when type and power both are same, steady state error is A by K. A means unit ramp. So, 1 divided by K. While you are finding K, numerator constants by denominator constant. Numerator constant by denominator constant is A. Therefore, A by K, which is equal to A into K power minus 1. This is the steady state error. Then what he is asking now? This is the steady state error. Now he is asking to find the sensitivity of the steady state error. First, sensitivity of steady state error with respect to K. Formula, see the formula and apply. Now, K by what is the steady state error? Steady state error is already calculated. A into K power minus 1. Next, differentiate steady state error with respect to K. So, A is constant, K power minus 1 differentiation is minus 1 into K power minus 2. Therefore, so K, you go to numerator K square, A by A minus 1 into K power minus 2. K power minus 2, K power plus 2, by A divided by A, which is equal to minus 1. This answer. Okay. Now, next one more thing is also asking sensitivity of steady state error with respect to A. Sensitivity of steady state error with respect to A, which is nothing but first denominator A by steady state error is already calculated, A into K power minus 1. Now, differentiate steady state error with respect to A. So, K power minus 1 is constant. Differentiation of A is 1. Therefore, A, K power minus 1 divided by A. All are cancelled. Answer is 1. This is the sensitivity of steady state error with respect to K, sensitivity of steady state error with respect to A, and these are the formulas, and you can apply. You can easily get the answer. Okay, note down. Okay. Now, if the same question he is asking like this, if he is asking sensitivity of a control system. Now, suppose he is asking sensitivity of a control system. Control system is control system transfunction with respect to K. Now, what is the formula? K by T into dt by Tk. Right? You solve this one also. Now, again, sensitivity of a control system means first control system transfer function with respect to A by transfer function, differentiate transfer function with respect to. This is another question. Okay. So, but what is a transfer function? First, you will need to find that. So, for a control system means you want to find the control system transfer function. This is the open loop transfer function. Therefore, what is the transfer function? The transfer function is nothing but numerator is numerator, denominator is denominator plus numerator, which is equal to K by S square plus AS plus K. Numerator is numerator, denominator is denominator plus numerator. This is the transfer function. Understand? Now, this is the transfer function. So, this is the transfer function, differentiate with K and K by T. This is the transfer function, differentiate with A and A by T. Okay, this you can use it. Okay, you can easily find. Like that, the questions are also asking. Okay. Now, this is the sensitivity of a control system with respect to, he may ask anything with respect to K or with respect to A. That's why it is a parameter variations like forward path gain, feedback path gain, system gain, and with respect to K and with respect to A and so on. Okay. So, now I want to find here. Now, this is the open loop control system transfer function. This is open loop control system transfer function G of S this is the open loop control system transfer function. So the open loop control system transfer function C of S by R of S is nothing but the transfer function, which is nothing but only forward path gain. Okay. Now see here. Now we'll find here sensitivity of open loop control system is control system transfer function. Now with respect to, first we'll see forward path gain with respect to G, which is nothing but G by T. What is G by T? G by T or T by G, which is 1. Next, transfer function is nothing but G. Now G differentiate with G is nothing but 1. Therefore answer is 1. Sensitivity of open loop control system transfer function with respect to forward path gain is nothing but G. G by T is 1. Transfer function differentiate with G is 1. So this is the sensitivity with respect to open loop control system. Now we will see the sensitivity of closed loop control system. Now this is the sensitivity of the closed loop control system transfer function with respect to forward path gain. So now what is the closed loop control system transfer function? The closed loop control system transfer function output by input is nothing but transfer function is nothing but G by 1 plus G. G by 1 plus GH is 1. Okay. So now see here G by T. What is the sensitivity? Now the sensitivity of closed loop control system transfer function with respect to forward path gain. G by T means 1 plus G. Now transfer function differentiate with G. Transfer function differentiate with G means 1 plus G is constant. Now differentiation of G is 1 minus G is constant. Differentiation of 1 is 0 by 1 plus G whole square. Now which is nothing but 1 plus G minus G by 1 plus G whole square into 1 plus G. So G cancel, 1 plus G cancel, 1 divided by 1 plus G. This is the sensitivity of a closed loop control system with respect to forward path gain. Now you first see these values and have some conclusion here. This is the sensitivity of open loop control system transfer function with respect to forward path gain is 1, is high. Here it is 1 divided by means less and decreased. Now which means that here the sensitivity of open loop control system is high, which means it is highly sensitive to noise, highly sensitive to internal and external disturbances. Highly sensitive to internal and external disturbances. Now come to here. Now sensitivity of closed loop control system is less, 1 divided by, it is less. Sensitivity of closed loop control system is less and it is less sensitive to noise, less sensitive to internal and external, less sensitive to noise and internal and external disturbances. Less sensitive to noise and less sensitive to internal and external disturbances. So why here it is less sensitive? Why here it is more sensitive? Because whatever the changes in the forward path gain which will immediately affect at the output. Is it right or not? Why? Because C, which is equal to G into R, whatever the forward path gain, that immediately changes at the output side. But come to here, whatever the forward path gain which will not immediately at the whatever the changes in the forward path which will not immediately at the output, because there is a feedback here. Whatever output, again it will compare with the feedback. So whatever the changes, if output should be changed, then the forward path gain is changed. It is not affected directly, and it is changed by a factor of decreased by a factor of 1 plus G. Then after that, then your output will be affected. Therefore there is a feedback here. Therefore output is not affected immediately. That's why this is less sensitive to noise, less sensitive to internal and external disturbances. Okay, note down. Okay, now students, now this is the same. Now in open loop and closed loop, the common parameter is forward path gain. Therefore you just think about, with respect to forward path gain, if you are finding the sensitivity in the closed loop control system which should be very less, then if you find the sensitivity of the closed loop control system with respect to feedback path gain, and it should be very less compared with this. So if you have any doubt, calculate that one also. So now actual the sensitivity is used to measure the effectiveness of feedback. Therefore now with respect to H, how the sensitivity is more or less, you see here. Now the transfer function, which is nothing but G by 1 plus G into H. Therefore now see here, now this is the formula, H by T. No, there is no relation of H by T. You keep as it is. H by T means nothing is there. H by T. Now transfer function differentiate with H. Now the transfer function 1 plus GH is constant. Differentiation of G with respect to H is 0, minus G is constant. Differentiation of 1 is 0. G is constant. Differentiation of H is 1. Now divided by V square, 1 plus GH whole square. Therefore this is anyway 0. So finally the answer is minus G square into H by T into 1 plus GH. So minus G square into H by 1 plus GH. What is T? What is T? Now T is nothing but G by 1 plus GH. Now this is T. T is nothing but G by 1 plus GH. So this G cancel. Finally the answer is minus G cancel, G H divided by 1 plus GH. G cancel, minus G H by 1 plus GH. Now you see the answer is not 0. It is negative, less than 0. Means the sensitivity of the closed loop control system with respect to feedback path gain, with respect to forward path gain is less, but with respect to feedback path gain is very less. This is negative. See here, the answer is negative. Very less. So what is the meaning of that? This is very less. This is very less sensitive to noise, and this is very less sensitive to internal and external disturbances with respect to forward path gain is less. And with respect to feedback path gain, it is very, very less, okay, because the feedback is a main parameter to measure the effectiveness of the system, okay. Now, how effective the system is working is based on the feedback only, okay. So, with respect to feedback, so it is very, very effectively working in the presence of noise. It will not entertain any noise signal or any distortion signal, because the sensing of noise is very, 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 very small. Means not sensed. It is not sensed. Okay, it is, but that is highly sensitive. If any noise, okay, accepted. If any disturbances, accepted. Where? In open loop control system. But in closed loop control system, noise signal is coming. No, it is the least bothering to noise. No, it is the least bothering to disturbances. Okay. So that is the reason why we always prefer a closed loop control systems. Okay, note on this. Okay. Now let us take if loop gain. This is the loop gain. If GH is very high, this loop gain value is very high compared with 1. So the sensitivity of the closed loop control system transfer function with respect to feedback path gain is minus GH by, if GH is very high compared with 1, neglect 1, so only GH, so which is equal to minus 1 is the answer. Okay. If GH is very high compared with 1, loop gain is a higher value generally, so this value is neglected, GH cancel, then the answer is minus 1. Okay. Now then, sensitivity is generally which is used to measure the effectiveness of feedback. Now with respect to feedback, the sensitivity is very, very, very less in the closed loop control system. Like that, he may ask anything, find sensitivity of a control system and with K1, with K2, with respect to K1, with respect to K2, with respect to X1, with respect to X2, whatever it may be asking. With respect to means that is beta. Okay. So this is one important topic, a sensitivity, a small topic, but it's very useful topic in the GATE examination point of view. Okay. Note on this.